You're welcome to another video. Now, in this video, I'm going to be making a comparison between Zig and Rust. So, Zig is a new programming language that I just found. I was going through some videos on YouTube, and so I've been taking a look at this Zig programming language, and it's a really interesting and you know, I found a bunch of interesting stuff about language, and I thought I should make some comparison with the Rust programming language because it's a low-level language just like Rust, and so I figured why not just make a comparison and see which one is better. And in this video, I'm going to tell you what language I think is personally better. By the way, I've been using Rust for I think about 6 months now, so I'm pretty familiar with the Rust programming language and I can use it. I've only been working with Zig for like 2 days, so I'm not really that familiar with the language. But from what I know, the Zig programming language is still in like version 0.9 or something. So it's not yet 0.9.1. So the language is still pretty young compared with the Rust programming language. This is like version 1.59. So a couple of differences between both programming languages is that the Zig community is really small. So compared to the Rust programming community, where Rust the community is quite large and Rust is a lot popular. But that's not what I want to get into in this video. So I've written a couple of bullet points here, and I want to make comparison based on this, right? So the first thing I want to go over is the installation. So when it comes to installation of the tools that we need to work with the programming languages, which programming language is better? So first I want to go over the Zig programming language. So as you can see, if you click on the get started here, then you're going to get to this page, which is going to tell you about how to install Zig. So if you click on the install Zig link here, you're going to find that you can directly download the Zig, compiler from the downloads page here. Actually, that was what I did. This was how I installed the Zig programming language. And as you can see, for Zig, the size is really small. This is just for the source code. This is just 13.9 megabytes, and for the compiler and all the tools inside of them, this is 38 or 41 megabytes, maximum. Right? Okay, this is even bigger for Windows, 61.2 megabytes. But you have to understand that the size of this binary is actually really impressive, considering the amount of two chains inside of the compiler. So basically, the compiler has a lot of things. It has the Z compiler inside of there. It also has a C compiler, and it comes with a lot of libraries, C libraries, and a lot of runtimes for cross environment for cross compilation. And so we're going to get into that much later. And so if you want to install it just directly download it, you can do that. I believe you can also, this is for setting up your path once you've downloaded your Zig. You can also use package managers to install it. So if you have Chocolate E for Windows, I believe, you can use that to install Zig, Homebrew for Mac. And of course, if you have, you can also build it from source if you want. And for Linux, is available for a lot of package managers. But my recommendation is that you do not install Zig from any of these package managers because I don't Zig, is really evolving pretty fast, and they make a lot of changes to the language. They have a lot of bug fixes and stuff. So you if you want to do anything with Zig, I recommend you just use the nightly version. I believe this is the master branch, so this is the one you should use. Right, so if you want to work with Zig, just use this one. Right, this is the stable. If you care about using stable, then you can just pick any one of this. But I think staying with the master branch is much better, and you get updates as quickly as possible. So speaking of Rust, installation is a little straightforward if you're running on Linux or Mac, I believe. So you can try Rust without installing using the Rust Playground. It runs on the web. But if you want to install Rust, then you just have to copy this if you're on I believe Mac or Linux. You can just copy this and go to your terminal and paste it. Once you do that, you press enter and you'll be able to install Rust. I already have the Rust toolchain installed. I'm not going to do it. If you want to install for Windows, of course, you have to click on this and you have to click on the other installation methods and you're going to find instructions on how to install um, Rust, for how to install Rust. And as you can see, there's a lot of supported like targets. So these are the targets that are supported, I believe. Um, let's see. Okay, this is Rust up in it. Sorry, these are the targets that is available for if you want to install the Rust toolchain, right? So you can make a choice. We also have standalone installers if you want to use that instead. So this is pretty comprehensive. So on the front of installation, I would say Zig and Rust. I would say Rust is much better when it comes to installation because when I had to install Zig, I didn't want to install it using the package manager because the version is going to be pretty old. But with Rust running on Linux, I could just copy um, what I found, the link, and then press enter, and it's just going to help me download and install everything, right? And so when you have Rust installs a couple of binary. For example, it installs cargo. You also have Rust C, and I believe you also have the Rust up. So Rust up is what you use to install and update the Rust toolchain. Um, yeah, I believe this is like all the tools that is installed by Cargo. I think I can find it if I do like list the Cargo. I believe it's been. Oh, so there's a bunch of things here that I've also installed, but this is installed by Rust, Cargo Creepy. I installed some that wasn't part of this before. Rust format, Rust doc. So it installs a bunch of tools that you're gonna need to work with Rust. And the only thing that you have in the Zig part is the Zig. So you have Zig. What is this? Um, I believe if I do, I don't know. Just do Zig. All right, I'll just do Zig help, and then this is what you find for Zig. So the only binary application that is installed for Zig is this Zig, um, executable. So make sure that you put that in your path, and that's pretty much it. So when it comes to installation, I believe that Rust is much easier to use compared to install compared with Zig, right? I believe you can also install the Rust toolchain from your package manager, so that is also there. Now, when it comes to the compilers and tools, my preference is actually Zig. All right. With Rust, I have to remember a lot of tools. Like for example, I want to do package management. I use Cargo. I want to compile my program. Sometimes I have to use Cargo. Sometimes I have to use Rust C. I want to manage documentation. I get to use Rust Doc. All of these tools. There's just too much to remember. I want to test my code. Then I probably have to do Cargo P or whatever. Like there's too much executable um, when it comes to Rust. But with Zig, the only executable you have to remember, the only thing you have to know is just Zig. It doesn't take much time to get familiar with just one binary file. All right. I believe just one application, the complexity. If I do cargo help, there is a lot of instruction. There's a lot of things, and the cargo build has its own help that I also will have to learn. Just take a look at this. And I have to figuring this out. I also have to understand Rust C, which sometimes I don't even get to use. I don't even understand how to work with the Rust compiler. The only thing I know is how to work with cargo because I don't ever use the Rust compiler. Cargo, talks to the Rust compiler for me. Then there is also the Clippy and a bunch of other binary. So for me, when it comes to compilers and tools, I'm just gonna pick Zig. All right. Now, when you talk about the features of the compilers and tools, of course, Rust has more features. But for the features that matter to me, Zig has everything I need. All right. If you take a look at, it just has build. This is for initializing an application, a library, same as cargo init hyphen lib to initialize library, or bin to initialize an executable. So basically, most of everything you find inside of here is exactly what is inside of the cargo. But Zig has a build system built in, which we're going to get into later. So when it comes to IDE support, of course, this goes to Rust, because Rust has a lot of IDE support. There's the Rust Analyzer, there's the Rust Language Server, which I think is deprecated. Zig also has the Zig Language Server, which I installed. By the way, when it comes to IDE support, or you can call it editor support, whatever, I also have some Zig, what is it called, installed in my Sublime Text. If you want to know how to do that, please go to the Zig website and you figure out how to install, tooling for Zig. But it's actually quite easy to install. But when it comes to IDE support, Rust is much better. There's syntax alignment, the Rust Analyzer really works great for almost everything. The only problem I usually have with Rust Analyzer is when I'm working with procedural macros. So, yeah. Um, with Zig, the tooling is not mature at all. A lot of things don't work. For example, completion, type inference. A lot of things just don't work out of the box. All right. Now let's talk a little bit about compilation. So, when it comes to compilation, what I'm trying to say is, first of all, I need to create a couple of projects, and then we're going to see how long it takes um, to compile a project, all right, for both Zig and Rust. Just a Hello World program, of course. So, in order to create a Zig project, we're going to do Zig init exe. But first, we need to create a directory, so I'm going to call it Zig exe, and then I'm going to cd into that Zig exe and then do Zig init exe again. And now it's going to create this build.zig, and I believe a main.zig inside of the source directory. All right. So if I run this, I could just do, I believe, zig build run. So this is how you are going to run a Zig, project. So you do Zig build and then run. And by the way, if you take a look, you see that we have a build.zig file, which again we're going to get into later. So time Zig um, build run, and we're going to see how long it's going to take Zig to build its project. Okay, and Zig is still running. Okay, so according to this, we have 11.45 seconds. All right, I'm just gonna take this. Um, okay, it says 16.128 total. I don't know what exactly does this time return. I'm just gonna take 11.45 seconds here. I'm sure if I run it again now, because it has done some caching, you see that this is actually faster now. But first run is what I'm going to use to determine this. Now I want to do a cargo new, then I'm going to do rust exe, and I'm going to cd to rust exe, And then you can see I have my cargo.toml file, which is the build file that cargo reads. And if I list my source, you can see I have a main.rs file, which is the Rust source file. Now I'm going to do cargo run. Oh, I have to do time cargo run. I think there's a target directory that gets okay. Time cargo run. And now if I run this, um, so Rust is building now, and there we go. All right, so this is just 1.71 seconds. That definitely took more than 1.71 seconds. I have absolutely no idea. Okay, here you see it says 9.70 seconds. Anyway, I don't really understand that. The time it takes to compile, I don't know who wins that because I can't understand what this thing is returning. So, yeah. Anyway, the next thing I want to go into is the package manager and libraries. So what does it look like with Zig? Zig doesn't have a package manager yet. I believe they're working on it. So this one actually goes to Rust because yeah. When it comes to the build system, now let's just open up this in Sublime Text. Um, so this is for my Rust project. Now this is the Rust this is the main.rs file, and this is the cargo.toml file. So the cargo.toml file is where you write your dependencies and you write, basically the metadata and everything associated with your Rust project. Now, if this isn't enough, you can also create a build.rs file, which cargo is going to run, and you can use that to initialize and do whatever else you want to do with the project. So Cargo really has a pretty comprehensive and complex build system. And when it comes to Zig, let me go back to the terminal. Zig exe. So when it comes to Zig, this is the build.zig file, and this is the main.zig file. So here you can see that a build.zig file is just another zig file. All right, Zig doesn't have, compared with like Rust, where you have another language for describing your project and how it's built. Of course, like I said, you can use the build.rs file to specify other stuff, but the cargo.toml file is required. So apart from having to learn the Rust language and syntax, you also have to learn about the TOML format. At least you have to learn about how to, do stuff like keys. To what do they call that stuff again? I always forget how the cargo the TOML thing. But with Zig, all you have to do is understand the language and read the documentation for all this stuff, and you're pretty much ready to start working. And the interesting thing about the build system, I believe I'm talking about the build system, right? Yeah. The thing about the build system is it's actually really complicated. For example, you can see here that it allows you to add executable. So you can also do something like add assemble. You can add multiple executables to build. Um, you can add options tests. You can even add like a static or shared library to be built, a text executable. If you want to translate like a C, which we're going to get into later, because Zig allows you to translate, C code into Zig. Basically, it has a lot of things that you can do here, without even stressing yourself. Like you already know the Zig language, so you don't have to worry about another kind of thing. But then, where is it? Um, you can't find it, right? But then the cargo.toml file actually, apart from the fact that it's another language, which is the one thing I don't like about Rust, Um, you know, it's pretty cool, but it's also Rust is a little complicated when it comes to the build system. If you're a beginner and you're trying to pick up Rust, you're trying to learn Rust, the build system is not easy to understand compared with like the Zig build system. So with the Zig build system, if you create a Zig project and you're just learning Zig, you can just ignore the build system and start learning the language. All right. Once you understand the language, you understand the syntax and everything, you can just go to the build of Zig and you just understand exactly what to do and how to use the build system. So for me, when it comes to being user friendly, the build system is for Zig is much better. All right. I believe that it even has or contains more features compared with what Cargo offers. And Cargo is really advanced, by the way, but I think I just like or prefer the build system of Zig. Yeah, I think that's all to say about the build system thing. So for me, I'll give that to Zig. Now, for documentation, there is no programming language that beats Rust. That's just the truth. There is no programming language that beats Rust. But the problem with documentation is that sometimes too much of everything is just bad. For example, when I started learning Rust, Rust has a lot of documentation. And sometimes I just felt lost. Like I didn't like there were too many books. There's the Rust C book, there's the Rust book itself, there's the Rustonomicon. There's just a lot of books in Rust that are huge and you don't really know what to do. There's also the cargo book. And you have to read all of these books just to get started with Rust. It's just crazy. But still, it's better for there to be documentation than for there to not be documentation. And the Zip project is still young, so it doesn't really have a lot of documentation. Most of the standard library components are not documented. And so for me, that's just no, 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 no. So Rust wins when it comes to documentation. Now, when it comes to testing, this is actually a stalemate for me because testing with Rust and testing with Zig is pretty much equivalent. In fact, testing with Zig is actually interesting, as you can see here. Um, you can test with Rust too. So if I want to run a test, this test now with Zig, all I have to do is do Zig build test. I can hit that to build the test, and I have to wait. As you can see, the test passes. I can also run a test in. I can also write a test in Rust by just doing um, test. I believe. Sorry, I have to do CFG test. Yep, and then I have to specify that this is a test, and then um, you know, I believe this has to be a macro. Yep. What is this? Okay, I believe this is just. So if I run this, there's nothing to do anyway. So I could cd to rest whatever, and then I have to do cargo test. And this is going to run exactly just like the Zig counterpart. But as you can see, writing tests with Rust is just, come on, like you have to do CMG tests just to make sure that Rust doesn't compile your tests. And then you have to specify like this test module like it's not I don't think it's like required, but where do I put the CFG if I don't have a module? So when it comes to testing, I think look at the way you specify tests with Zig. You just have the test keyword, and then you have the name of your test, and then you can start testing. Like for me, this is just easy. I don't have to do some stupid CFG. What the hell is this? Like, why do I have to do this? Why can't Rust just have something like, I don't know, test form or whatever? Like, this function cannot be called from anywhere else anyway. So why don't we just have like a test function? This is a text function. Why do I always have to like annotate it with this test macro? have another test macro here and put it inside a module. For me, when it comes to testing, I think I prefer like the Zig testing. So I'm going to change my verdict and say that this is actually going to be given to Zig. All right. They both have like the equivalent, functionality when it comes to testing. When it comes to ease of writing tests, like I could easily write tests like however I want it. So I'm just gonna take Zig. Now, when it comes to cross compilation, Rust supports cross compilation. Zig also supports cross compilation. Now, there is a fundamental difference between both programming languages when it comes to cross compilation. For example, I do not think that it is possible for me to cross compile. Like with Zig, I found that I could do something like build, I believe, yeah, what is it called? Target. I think it's Windows. I just have to remember. Is it Windows? Yeah, I guess. So I want to build. What I could do with this program is I could actually build a Windows executable right from here. I'm trying to remember if I can remember how to do it. I'm just gonna say Windows, and then we're gonna see. Okay, that is incorrect. So we're gonna check. Um, what is this? Okay, it says unknown architecture. Okay, so I could do Z targets, and then I want to grab for Windows. I always forget. Like, yeah, it's just Windows. Maybe not. Yeah, okay, so I've seen it. This is x86 underscore 64. Uh, no, Windows new. Yeah, GNU like that. Now, I could build an executable for Windows right here on my Linux, which is really crazy. Like if you go to the Zig out, then the bin, you find that there's a Zig exe.exe, and then I think this is like a debug file for Windows. And if you do Zig exe.exe, you're gonna find that this is actually a valid Windows executable. All right. I don't think this is what Rust is capable of doing. And by the way, I didn't have to install anything else just to cross compile. You can cross compile to so many platforms in Zig without having to install anything. Now compare that with Rust. Even if Rust is capable of cross compilation, which I think it is, but it doesn't have any linker. Like you can see that we just compiled and linked a Windows program without having anything installed. Like Zig just did everything for us by itself without requiring us to do anything. So this is really important. With Rust, that is completely impossible. Like Rust doesn't ship with a linker. Um, so Rust cross compilation is actually, let me just say that it's not possible to do cross compilation in Rust because you are going to require, like if you want to compile an Android library for Rust, then you're going to need to use the Android linker. But you can actually compile an Android library with Zig without requiring any thing from the Android SDK, I believe. So yeah, I think I tried that and it worked. So with Zig, for me, when it comes to cross compilation, Zig actually wins. All right, Zig is just better at cross compilation, and yeah, that's pretty much it. And speaking of cross compilation, all the tool chains that you require, like if I do Zig targets, you're gonna see that there is a lot of targets supported by Zig. Like there is a lot of them. I don't know. See, my terminal isn't even able to scroll anymore. But if I do less, you're gonna see that there's a lot of architecture supported out of the box by Zig, and all of these just with the 40 megabytes of download size. This is just crazy for me. And yeah, but when it comes to Rust, you have to install the two chains you require, which is probably like, I don't know, 40 megabytes per 2 chain. When it comes to like the binary size and constraints of like everything you need to work in your programming environment, for me, Zig is just better at that. Period. Now, when it comes to C interrupt, now what I mean by C interrupt is simply how you communicate with C. For this one, I'm going to give this to Zig. And the reason for that is simple. The reason is because Zig is just crazy when it comes to working with C. Like, you can literally just come here and be like, C equal to C import, and then you could do like C include, and then you could include something like stdio.h. And then you could, instead of using like the standard library log info, you could do something like c.printf, which is just gonna work like hello from Z, hello from C, because I'm using the C thing. Now the interesting thing about this is if I do zig build run, this is not gonna work, of course. It says libc headers not available. Compilation doesn't link against libc, which is easy to fix. Um, all you have to do is take this executable target and do exe.link libc, and that is all you need to link to libc, and you're done. This is gonna work. You just have to trust me that this is gonna work. Once it's done doing all the code generation and linking, of course. Um, so you can see that just by writing a simple link libc, um, okay, I think this is really like generating all this stuff, all the libc stuff. And I believe this does this like only once it's done. Okay, so there's an error here. This is a Zig issue. So it turns out that printf returns a value, and Zig always requires that you use a value that is returned by some function that you call. And this is a way to ignore the result of such value. So now if I build again, you see that this is going to run a lot faster than before. And just like that, I can call any C function that I want from Zig, and I can just include the header files from here. Now, if I want to do the same thing from Rust, it's just not possible by default. The first thing I'm going to probably have to do is to install the, I believe is the C bindgen, or is it C bindgen or Rust bindgen? Like, I confuse those two programs. Yeah, so I require the Rust bindgen, crate. So I'm gonna have to first import the Rust bindgen crate, specify some header file, then it generates it. Or I use my like it's just complicated to interrupt with C from Rust. But with Zig, it's just easy. Like you can even use C macros directly from here. And yeah, that's pretty much it for C interrupt. Like Zig just blows Rust out of the water when it comes to like C interrupt. Now error handling, which is really gonna be the interesting part of this video. Now we all know the error handling for Rust is pretty straightforward. Um, so there are two ways to handle errors in Rust. To take care of errors in Rust, and that is using the option type. So, for example, um, um, so if this is a function that can fail, then the function returns an option, all right, or a result. In this case, we're going to use option. So the option type can either return an option of like, I don't know, an I32, or it can return null to indicate none to indicate an error. All right, and then if you want to use it, you can match on the failable function, and I'm going to use the code completion here, and then the value here, and yeah. So and then you can print. Um, so you can print the value, or you print got none, pretty much. Now, this is exactly how you write functions that can fail inside of Rust. And if the function returns a result, then it's actually going to be two types of man. So, result, for example, and this is going to return a result of either, let's just say, an I32, or it's going to return nothing basically, right? And then we can return like an error saying that we got nothing here. And now we can also match on these three results, and you're gonna get the same thing pretty much. But this is going to be an OK, which is going to be um, here. We're also gonna also have an error, and then we can handle both as we see fit. And this is exactly how you write like what is this? Okay, this is we don't need that. So this is exactly how you handle errors inside of Rust. This is like mostly how you're gonna write and handle errors in Rust, right? It's just something that returns an option, and if it's a sum, then you get a value, and if it's a none, you get nothing. If it's a result, then the OK part of the enum is what contains the result, and the error part contains the error result, which is really nice. I think it's much better than how most other programming languages handle errors. But wait until you see how Zig actually handles its own error. So here, this is a main function, and as you can see, there is this any error type, and then the semicolon, and then void, which is interesting, all right? So I'm going to show you something here. I'm going to have a function, same as this, function variable func. We use camel case when we write functions in Zig. So it turns out that a function can return a result here. What did I return here? I32. So it turns out that a function can return a result. So the exclamation mark, so you have like, for example, sometimes um, you can specify like error conditions like this, where what is this? Um, so this is exactly wherever you find this semicolon in the return type followed by the actual value you want to return, then this is exactly how Zig, I believe, does error handling. Most of the time, the error type is inferred, and this is the crazy part of Zig that I found. All right, and I really like this, by the way, and it is that you can actually make up errors inside of the function. Now, some people are not gonna like it, and I understand. Like, for example, some people prefer to just have like an enum where they specify like their errors and such, or whatever. But for me, I prefer to just do it like this, where I haven't really learned much about how the error handling works, and I think I've forgotten most of what I learned. But from what I know, if I wanted to return like an error here, I can return error field, for example. And as you can see, this error that failed is not like I didn't make it from anywhere. So how can I use it in my program? Well, it's really simple. All I have to do is call failable func. And the interesting thing is, if I try to compile this program, um, you're gonna see that the compiler is gonna complain, and it's going to say that error is ignored. Try using try catch or if. And if I do try, for example, you're going to see that my program is going to compile, but then it's going to return an error. What's this? Expression value is ignored. Yeah, okay, so yeah, this returns an I32, so I have to ignore the value because I don't need it. I know it's going to return an error anyway. So you can see that the program actually ran and then it crashed. So this is the stack trace, and as you can see, main.zig 11:5. So it says that the program failed. And so the error here, as you can see, is failed. Let me just change this so that you can see that this is actually what happened. So you ran the program and then it got to that error, and then printed a stack trace because the program crashed. And let's see. So field error, as you can see here. Now there's a better way you can do this, and the reason I'm able to do this at all is because the main function actually returns on any error, and that's why you see the stack trace. Now if I try to run this now, the program is not going to compile because as you can see here, we cannot return and something that can fail. All right. So now we have to handle the error, and the way to do that is to do something like catch, and then maybe like 20, for example. So the way catch works is that we can decide that okay, if this returns an error, then we want to catch the error and provide a value, for whatever it is. And this is really nice compared with like Rust. I believe Rust has a lot of things. As you can see, the program didn't crash this time; it actually worked. Now with Rust, you can do the same, by the way, where you could do something like dot map map error, I believe, or you could do something like dot wrap or and then you can provide the value you want. But for me, it's just easier to read when you have something like this. You just say catch and then you do something with the result. You could also catch the error and print it out, for example. I believe. Yeah. Let me see if I have the right syntax here. Um, I believe. Um, let's see. So I want to catch the error and I want to print the error out. So std log debug. So error and I believe. Nope. I have to put this in the syntax that looks like this. I believe I recommend you go learn about the Zig like syntax and stuff. Okay, so as you can see here, this didn't work. Let's see. What do we have here? Maybe I cannot specify that. Alright, so when you catch, it just prints this error message out here. Which is interesting, right? So that's how you can catch. I thought you could like catch something and then return the result, but apparently you cannot do that. So anyway, that is how you do error handling inside of Zig. And for me, the fact that you can lazily specify errors like this, error that failed error, for example. And by the way, you can also do switch on this error. Um, Alright, sorry, switch on E, and then you can do error that failed error, and then you can do something like log and debug. I believe that's it. Yeah, so let's just check and see if that works. Nope, it doesn't work. Okay, sorry, I missed one thing here, second argument. And now you can see that the program works. It says failed error. And how did it know that failed error is what we're going to get here? Because the only error type we return here is actually a failed error. Anyway, um, so when it comes to errors, I will give that to Zig because I love Zig's error handling. For me, I think it's much better than what Rust provides. Now the complexity of your programs, like how complex is your program? For me, Zig is a less complex programming language compared with the Rust programming language. Now I've been using Rust for a while and I really love Rust. But the thing I've been learning Zig for like what 2 days now, and the language already feels familiar. It helps me get rid of a lot of things. I do most of what I do is FFI. I interrupt with like Android libraries. The NDK pretty much. And when I'm using Rust, I always have to like write bindings to the NDK. And even when I use like the Rust bindgen library, I will still have to like write wrappers to to make sure that I provide like a safe interface to Rust. And there is just a lot of work to do. And even with that, I still have to worry about cargo, linking my C libraries, and a bunch of other stuff like that. And also cross compilation, like there's just a lot of. So when it comes to complexity, Rust is definitely more complex. Now, is this a good thing or a bad thing? Now, for me, I love simplicity, and that makes me want to lean to the favor of Zig. Now, like I said, Zig for now is, for me, I believe, is not as good as Rust yet because like there's still some things that are missing in the language. For example, the language doesn't have closures and stuff like that. But for me, when it comes to complexity, I love when it is small. Like when it complex, when a language is simple, I can really grasp exactly what the language does, and I don't have to think too much. For us, there is the borrow checker. When I'm writing my program, I have to worry about it. There are times when I cannot use the pointer type. Basically a lot of like there's too much complexity with Rust. So I'm going to go with Zig in this one. So that is all I can come up with the comparison. So let's see who wins this one. So we got one, two, three, four. Uh, okay, so for Zig, what do we have? One, two, three, four, five, six, seven. Whoa, that's crazy. All right, so what this means for me, at least, is that Zig is just a better programming language for systems programming language for systems programming. And one more thing I want to talk about, I think I should probably talk about it in another video, is why Zig is a better programming language compared with Rust, for example. And one of the things I think I don't like about this Rust programming language is how Rust programming language handles things like memory, for example. But that would be something I will address in another video. Thank you guys for watching, and I'll see you guys in the next one.